Hello and welcome to the VMware Cloud Foundation Live, a monthly live stream where we discuss strategies and solutions for your cloud infrastructure journey. My name is Pete Fletcher, and I'll be your host for this episode, where we're talking about VMware Private AI Foundation with NVIDIA. Now, I'm sure a lot of folks know that generative AI has just been transforming the way companies do business in much the same way as the PC did, the internet, and even smartphones. And there's a lot of money to be gained for companies to take advantage of generative AI. But there are some challenges, certainly cost, security, and privacy, to name a few. And so it's a really interesting topic. VMware's got a great solution called, as I mentioned, VMware Private AI Foundation. And joining me to share all the details about this awesome solution, particularly the VMware Private AI Foundation with NVIDIA, is my good friend from the vSphere product marketing team, Justin Murray. Justin, welcome.
Thank you, Pete. Nice to be here. Thank you.
So Justin, I've seen you present this both internally and externally. I think it's a really exciting solution. And I know a lot of folks that are just getting used to VMware, getting used to generative AI in general. Maybe they're using ChatGPT or maybe just toying with large language models and stuff like that. Give us the high level before we dive too deep. But tell me, like, how is the industry, doing generative AI these days?
Yeah, thank you, Pete. And it's great to talk about this subject. There is a huge amount of interest in it, as you said. And I'll show a slide in a second that has the industry adoption and how that's going. But essentially, people are using this as a competitive differentiator for their business now. My competition is doing this, I've got to do it too. And people are applying it to such diverse fields as source code generation, contact centers with chatbots, and anywhere that the documents need to be summarized, this is applicable. So, I'll talk about the core challenges to all that vision, but let me show you where industry is going, first of all, and then we'll get into the components in some detail. So,
Yeah, sounds good.
every industry that we talk to is interested in this. It's not exclusive to one vertical. It's not just finance or just healthcare. It's everybody, and everybody sees an application for this. And I think part of the reason they see an application for this is a general purpose thing. This is knowledge search at its best. You've been using browsers to find things. You get 100 answers when you ask for a document or on something. You don't get any summary. You don't know where it came from. This is kind of a replacement for that in some ways. This is a way to talk to your data using English such that you can get what you want. And so, finance is using this for personalized banking, for giving their customer sales representatives a better understanding of where the customer is. Drug discovery, finding new molecules in healthcare, fraud detection in telco, looking at churn and looking at other aspects of the business. Manufacturing, great example is, watching the process line and predicting where machines are going to go wrong or where a product has gone wrong. Federal is very interested in this. Defense is very interested in this, for example, and energy, doing research into various sources of energy, that sort of thing. So everybody's got a lot of information that they want to feed into a large language model. Not everybody wants to go public with that information. And that's the kind of VMware point of view, if you like, that there's a lot of valuable information inside VMware. There's a lot of valuable information inside every company, but I don't really want that information to be exposed. I
Yeah.
don't want to use it with a public facility, a public cloud, if you like. And so I want to protect my intellectual property. There are actually a couple of examples of intellectual property being compromised as a result of using public cloud-based LLMs. I really need to protect my private data. I want to make sure that only valid people get access to that. And I want and with these machine learning models, and we'll talk about models quite a lot, those are the sort of core thing in this world. Those AI models, can they be attacked? Yes. Can you say silly things to them, get silly answers? Yes. So people want to control that in a business context. They want to have private access to reliable information in a way that secures their intellectual property. That's kind of the motivation behind VMware's work, and other companies are getting in on this as well. And it's really about privacy, and that's why we called it VMware Private AI Foundation with NVIDIA. And we've been working with NVIDIA for a long time on this now, and trying to offer a solution. And the real point of view that we have to offer you as a sort of opinion, or a curated opinion on this, is that there are a lot of large language models out there now for you to use that are pre-trained, that are, Llama 2, Llama 3 are the famous ones, but they're not the only ones. They've already been educated on general purpose data that's visible to everybody. And we think you should choose one of those, test it for yourself. We're doing that ourselves with our own models. And there are models from NVIDIA and other people that have been validated and performance tuned and really quality assured, if you like.
Well,
Now,
so
sorry, now,
Justin, sorry to cut you off, Justin. I'm just curious because these large language models, they're large, obviously, and they have language. Just kidding. No, but these large language models are. It takes a long time for those to process and to actually become this model. I mean, that's why like the first version of like ChatGPT was so old, and everyone had to use this dated data because it just takes so much time to get that data in there. So
right.
I'm going to ask you multiple questions throughout this thing. And this is my cue to say, if you're listening to this live, jump in, add questions, and Justin will answer them as we go. But my first question to you, Justin, is like, how do we take advantage? How do we not reinvent the wheel? Like, how do we take advantage of what's already out there with these large language models, but then do that privately?
Yes, that's a great question, Pete. And it's along the lines of taking a trusted large language model from a trusted source, NVIDIA, VMware, other places, and customizing it with your own data, effectively saying, it's great that you understand general knowledge that's available in the outside world from Wikipedia or from other sources. The Pile is a famous data source. But really, this model becomes valuable to my business when it knows about my business data. And that's the customized LLM with domain-specific data, and then deploy that LLM in-house to serve up an application in inference mode. So we want to find the most amenable possible way of doing number two there, of customizing LLMs with domain-specific data. And one way to do that is not have the LLM changed at all, but to add to it a database that contains my private data. And we'll get into that theme. That theme is called Retrieval Augmented Generation. We think that's the on-ramp for this type of work, that this is the way to get started on this type of work. So let me first show you the toolkit that we give you with VMware Private AI Foundation, which is now generally available and is a joint thing between NVIDIA and VMware. And it's based on VMware Cloud Foundation that you see in the middle of this picture here. VMware Cloud Foundation is VMware's robust enterprise platform, includes compute virtualization, network virtualization, storage virtualization, and the management of all that. On top of that, we've layered a blue layer of components that we think are useful for the data scientists to use. Deep learning VM images. Bring up a VM very quickly with deep learning tools in them. A vector database, which we'll get into in detail. That's a real central component for retrieval augmented generation, for adding that database into the LLM so that the LLM doesn't have to do all the work. Catalog setup wizard really means, how do I automate all this so that it's easy to do it, that a data scientist could do it. They don't have to open a ticket with IT to do it. A data scientist could provision their own development environment or their own production environment. And then finally, how well am I using my GPUs? Am I making use of them, or are they idle most of the time? And on top of that, NVIDIA has layered a bunch of components. They're really just containers. NVIDIA NIM stands for NVIDIA Inference Microservice. NVIDIA Retriever, as its name implies, gets things out of the databases and supplies them to the model. And the other two those operators are Kubernetes functions to make drivers and other containers much easier on Kubernetes. the collection of these things together we call VMware Private AI Foundation with NVIDIA. The green layer is NVIDIA products. You buy them from NVIDIA as part of their NVIDIA AI enterprise. The blue layer is a VMware add-on to VMware Cloud Foundation. It's a separate SKU that you purchase from us. You put it into your VMware Cloud Foundation, and you have a lot of tools to get going on this world. A question I get asked regularly: how do I get started on my private AI work? Well, we'll give you example applications. There are example sample applications for you to get started on that. So
Okay.
that's, if you like, the sort of value of VMware and VMware Cloud Foundation in this picture.
So if let's just say I've got a VCF environment, I'm an administrator, and data scientist says, look, we're really getting excited about this generative AI stuff. We've already got these nice GPUs that we want to, that we've just purchased. It's part of it's already inside of my VCF infrastructure. If I've got VCF, all I really need is this, and I already own the licensing for NVIDIA. I just need to do an add-on for VMware Private AI Foundation to actually take advantage of this.
That's right. That's right. It's an add-on to VMware Cloud Foundation that you purchase from us, and
Okay.
it contains these four things that we're going to get into now in a bit more detail. So we'll focus in on this layer since this is VMware's main offer here. We'll say a little bit about the green layer as well, but I want to go into too much detail about that. And
Okay.
we're starting with this catalog wizard, which is code phrase for us for automation. And what we want to do is give a data scientist or a DevOps engineer who's working with that data scientist, or a VMware admin who's working with that data scientist. We want to give them the easy path to getting straight to their data science, not worry about VMs, not worry about networking, not worry about storage, not worry about GPUs. Present them with a simple two-screen setup, and they're ready to go. And let me show you that very briefly, and we'll show this in demo form as well. So we're making a new request here for a new deployment of AI workstation. Under the covers, we'll show you what's going on there later on. But all the data scientist really has to do here is say, do I have permission to use two GPU A100 or H100s to service my job? And for any sizable model, you're going to use at least 1, 2, or 4 GPUs to service it, and that's going to be allocated to you in advance, and you're choosing it here as a data scientist, and then you're choosing the software package that you would like to deploy for your work. Perhaps it's Jupyter Notebooks with example applications in it. Perhaps it's a Retrieval augmented generation setup that you've been working on for some time, and that's going to be provisioned now into one or more deep learning VM images that we've already given to the administrator, put them in the content library so that they can quickly provision them. And with a little bit of automation behind the scenes here, you don't have to touch this. You've made your choices already. You get what you wanted. You get your Retrieval augmented generation based chatbot provisioned for you, ready to go with a notebook to develop it further. And you're ready to execute this application. This is a sample application from NVIDIA that runs against some containers that we've just deployed for you.
Wait, so if I'm the administrator, am I able to I have to set this up for the data scientists themselves, or can I create like a store, like where they can actually, if they've got the appropriate permissions, they can just say like, hey, I'm testing this. I want to provision this, this environment, and I want to, start working on this new program. So click, finish, or do they have to go and like set up a ticket and some administrator creates it for them?
They don't have to talk to anybody, Pete. They go back to my two nice screens at the beginning and say, I'm very familiar with what an AI workstation is. It's for me alone. Or I'm
Excellent.
very familiar with what an AI Kubernetes cluster is. It's something that I'm going to deploy inference to. They click request, they add in a few of the parameters that I showed you, and it's done for them. There's no tickets, there's no need to talk to anybody, provided they have the rights to get those GPUs and to get that package of containers that was called RAG here. Provided they have access rights, they have the NGC API key to do it, then it's completely self-serve here. And
Well,
that's
yeah.
what we want. We don't want them worrying about what's the underlying infrastructure. We want to take all those infrastructure concerns away from them.
Well, at
Uh,
the same time, what we want to make sure is, these things are not cheap, right? So I actually heard a story about like some new hires at a company that were just like taking in all the resources of these GPUs and costing, they were getting charged all this money for using these resources, and these are valuable resources, and we want to make sure they're getting to the right place. So I'm assuming there's also some level of like permissions and saying like, this data scientist has access to this, so therefore they can take advantage of these. Whereas maybe someone like Pete can't be, taking advantage of these because he shouldn't be playing with GPUs.
yeah, absolutely. Behind the scenes here, a lot has been set up in advance for the data scientist. There's a notion of assigning certain categories of GPU usage to certain people, and they can see those and make use of those, and other people can't. And there's
Okay.
also the notion of what rights do you have to what software. We take care of that behind the scenes here. We hide that from the data scientists that might be using this, but we take care of that behind the scenes. And behind the scenes also is a deep learning VM, one or more of them. This is a regular VM that you would see in our standard user interface for managing VMs here. So anybody who manages VMware today, VCF, would be very familiar with the navigation on the left-hand side here that's presenting just host machines and VMs together. The only thing that's unique about this deep learning VM is it was assigned the two GPUs there that the customer, the data scientist, asked for. That was done automatically for them. They didn't have to worry about it. The administrator set those GPUs up in advance. And secondly, that VM was booted up, and at boot up time, the VM was downloaded with a whole bunch of tools, the RAG application, PyTorch, maybe Triton Inference Server, which is NVIDIA's inference server at scale. And those were loaded for the data scientist into this deep learning VM, where you see the base image there has got Docker and some vGPU settings. Virtual GPUs, by the way, are a virtual representation of GPUs that can be moved around in the data center, and an Ubuntu operating system. So that base image is supplied by VMware to you in advance, and these packages of software that the data scientist would love to use are downloaded as containers from NVIDIA GPU Cloud and deployed on top of the GPU driver in an automated way. So that's the magic behind the scenes of that deployment that I just showed you. Um, and we can do the same thing with vector databases.
Vector
Um,
database. So that's a term that I'm sure a lot of folks are not familiar with. So that makes sense so far. We've got this infrastructure that's been set up, VCF, super easy, right? It's already there. I don't have to relearn how to, I don't have to be a Kubernetes DevOps hipster to get all of this up and running. I can provision this information as a data scientist. I've been assigned the permissions. I can start taking advantage of it. I can actually start doing the work that I know how to do pretty quickly. But now we're talking, but what about the actual data that's private, right? Like there, we already understand large language models and all of that stuff gets pulled down, and there's a local copy of it, and these VMs have now been provisioned for me that actually, these deep learning VMs. But when we say vector database, how does that part of it connect to the public side that we already have?
right, right. Great observation. I want to be called a Kubernetes hipster from now on around the hallways in VMware. Um, this vector database is going to be a core piece for implementing retrieval augmented generation, which was a point of view that we have as a starting type design that you would use. And let me give a bit of background to this and build it up for you. So we're not asking you to train Llama 2 from scratch or anything like it. It takes a large amount of GPU power. A lot of data scientists are involved. A lot of resources consumed, a lot of CO2 generated. That's a
Yeah.
big job that we're not asking you to do. We're asking you to take a similar model, Llama 2, from the open world that's commercially licensable, and apply a little bit of change to that model, perhaps. And the types of change that are commonly perceived out there in the world are prompt engineering, fine tuning, and retrieval augmented generation. I'm going to spend more time on the latter than on the first two. We also support prompt engineering and fine tuning, but we see retrieval augmented generation as definitely something the world is excited about. The world of data science is very excited about it. There are lots of conferences, webinars about it. Lots of people are using this as their on-ramp to private AI or generative AI. So we'd like to show you the capability that we have for doing this. Instead of tweaking prompts on the far left, or instead of supplying small quantities of data to your newly downloaded Llama 2 or Llama 3 model, we're asking you to put your private data into a vector database, which is the tie-in to what you were asking me previously. And that data is now easily changeable. It can be secured, it can be encrypted, and you can find where your data came from. You can find the sources, the citations of that data if you want to. So it has huge benefits. Large language models are fantastic. They understand language and they can do a lot of work on your behalf. But we don't think they're standalone as the solution to this private AI problem. They've been known to hallucinate. They've been known to make things up. They're not up to date unless they're trained every day, which is a big task. And they don't really give you tracing of where they got their information from. They can't cite their sources like a journalist would do. We got this from paper X and paper Y. You don't really get that. So in order to take on these challenges, we think retrieval augmented generation and the vector database that is at the core of it helps you tremendously with making sure you have validated information, making sure you can bring it right up to date to today's data. The model was trained 3 months or 5 months or 6 months ago. If it hasn't been retrained since, then its data is out of date. Well, the vector database can be bang up to date depending on your refresh of data loading into it. And also you can get the documents from the vector database from which it got the answer to your question.
But the vector database is that information that's only internal information, or is like what's
Yeah,
inside that database? It's just
that,
my
that
information, right? It's not like the
that's
stuff that's in the large. Okay, got it.
that's where the private data comes from. Yes, the private data is uploaded into this vector database, and it's tokenized. It's in embedding form. It's in numeric form, such that you can get answers from it quickly. If I were to say, tell me all the knowledge base articles inside VMware that have GPU references in them, or virtual GPU references in them. That would be a decent Google search. I want to talk to the chatbot and get that answer summarized for me in one paragraph. That source of data is the vector database. And let me show you how that works very briefly here. So we have an application, maybe it's a chatbot or another client application, and we're going to issue a prompt or a query, and we're going to have that query encoded. And the query is first of all going to go to the vector database before it gets to my large language model. And the vector database is going to say, well, here are 5 KB articles that refer to virtual GPU for you, or here are 5 KB articles that refer to some private data that we absolutely want to keep within the walls of the enterprise. And it's going to return that enriched data back to the client application. The application is then going to say, here's my original question, and here's what the vector database contributed to me as a result of that question. Can you, Mr. Large Language Model, process this for me? Summarize it. Give it to me in plain English. Tell me what the sources are. Don't make anything up. Don't hallucinate, but give me the answer. And so you can think of these two as partners in answering your question. The vector database has given you the private data. The large language model has massaged that private data into a reasonable answer. And so the two of them are working together. And this is a design called RAG, or Retrieval Augmented Generation. And it provides all the benefits of security, up-to-dateness, ease of use. This is based on very familiar relational database technology like PostgreSQL. We've been supporting this at VMware for a number of years now. And what we have is a tool for automating the deployment of that and layering on top of it the vector layer, PG Vector, which is an extension to Postgres. We do that through a VCF tool called Data Services Manager, DSM. on the left-hand side there. So that too is automated. So you don't have to worry people about what are all the details of installing Postgres or installing PG Vector. That will be done in a quick and easy fashion for you.
Nice.
And
Okay.
that sits alongside your LLM as a sort of partner in answering questions, where the vector database is going to have your private data in it. And how private is that data? Well, we know that Postgres encrypts its data, or can encrypt its data. We know there's role-based access control to Postgres data. So a lot of the relational quantities that have been there for years and are tried and trusted, we can make use of here to control access to that data.
Okay. Okay. So that sounds like a really nice pairing, because obviously the vector database is just a database, right? So if I was to query a database, usually I'm just going to get I'm going to get numbers, or I'm going to get information that basically says, all right, well, here's every, in your example, here's every time I saw, something that was GPU. It'll try to, maybe more specific, like, the most, how many GPUs, which ones are in use, whatever the question is, it's only going to
Yeah.
return, the data is just in a database. It's only going to be able to present like what fields match that criteria. But then when you pair that up with the large language model functionality, it can convert that into a real answer, and maybe even shape it, right? Like, I'm assuming you
Yeah.
can literally, just like any other, maybe like OpenAI prompt, say something to the effect of, give this to me as if you were a poet, and then it would say something, like, and then it would have that ability to say, I'm manipulating this internal data, but I'm using special tools inside of this large language model to then create the answer in an English form, and I can make that as custom as any other large language model could. Correct?
That's right. That's right. The large language model is particularly good at taking sentences and paragraphs that are in embedding form, which means numeric form, and generating new representations of them, new forms of English. So the reason the word vector is occurring here is because there is some magic going on under the covers, where all the data that we load into that vector database is converted into numeric form. That's called embeddings. And with that, good searches, rapid and accurate searches can be made to find particular keywords and particular documents that refer to those keywords. That's slightly different from the relational model, but related to it. And then, given a set of documents returned in embeddings form, the large language model can make sense of it and make sure that it's good English, or good whatever your language is, to return to you as a sensible answer, a summarized answer. And all of this is using your GPUs pretty heavily. And so we want to see exactly how heavily. I mentioned models. I mentioned large language models. There's actually two models at work in a RAG design. There's a model that processes the language, the large language model, and there's an embeddings model that's also executing in a component called a retriever that's also executing against your GPU. So your GPUs might get hot when this happens, and we want to show you that in a nice graphical way. And this is a representation of VCF operations here that shows three main panels. One is to do with temperature. It's all green there, which is happy. Another is to do with core utilization, and another is to do with memory utilization. And so we want to be able to trace around in maybe dozens or even hundreds of GPUs across multiple clusters of machines. Where are the troublemakers? Where are the GPUs that are in trouble? Maybe they're overheating, maybe they're fully consumed. Maybe we need to add more power to our large language model or our deep learning VM than we had previously. So this gives us a view into how consumed those GPUs are and where any trouble spots might lie. As you can tell here, red is trouble. In the right-hand cases, it just means underutilized. So it's not real trouble, but it's you're not using your GPUs as much as you could be, and that's an indication that I could shift workloads over to those clusters
Yeah.
and relieve some other clusters. So this is really a tool for capacity planning, but also for day-to-day monitoring of what's going on. Each colored block represents a GPU within a server, and each of the titles at the top represent clusters of those servers. So we can drill down right from the top to the bottom, from the cluster, which is a grouping of physical hardware, down to a particular server, down to a particular GPU, and tell you this one needs attention. Uh,
Yeah, so that's really powerful because I would imagine, obviously these resources are not cheap, right? So you want to make
yeah,
sure that you're getting the most, and of course they're going to be in high demand depending on the level of work that your company's doing. You're going to make sure that everybody gets access to these, and because of the fact that you can move them and reassign them, this is a virtual environment. If I needed to reassign these to another virtual machine, I could do that. It seems like that ability to manage these resources, but see which ones, like you said, are being completely overused or maybe underutilized, and then
right.
be able to, manage that from an administrator perspective. That seems really powerful. What do I need to do to see this? Do I have to buy extra software? Is this built into vCenter? Like, how do I see this information?
Yeah, this particular set of features that I'm showing you here is part of VCF operations, which is a tool within the VCF portfolio, and you get this with VCF operations and standard VCF. So you you'll get this as you purchase or install modern VCF 5.x essentially. Uh, uh, these GPU features are part of the VMware Private AI Foundation with NVIDIA, but they're embedded into VCF for you there. One of the management tools that management would like to see is across my entire clusters, how consumed are my GPUs, or how unconsumed are they? How free to be used by other workloads are they? So there are summary level graphs here as well as drill downs. It's a very powerful environment. I think personally, this is going to be hugely popular among people who manage data centers and are watching these GPUs and watching the consumption of them. Uh, Switching gears now a little bit out of the VMware Private AI Foundation with NVIDIA into the NVIDIA offerings, and I'll be brief here on this. One of the core offerings is NVIDIA Inference Microservice. Think of this as a microservice, a container deployed either using Docker onto my deep learning VM or using Kubernetes as a regular microservice. Of course, there will be replicas of this running, but this is a pre-built container that you download, that we actually did download from NVIDIA as part of that deep learning VM. And when it says industry standard APIs with NVIDIA cloud standards there, what that really means is if you were building an application for OpenAI with its APIs, those same OpenAI APIs could be used against this NIM component uh, by
Ah.
simply by simply changing the destination to which you're sending your API call. And suddenly now you're doing on-premises application development in exactly the same way you were doing public cloud application development. So if you did your first experiments with generative AI on the public cloud using OpenAI APIs, everybody's using these. Then now you can do that on premises with this NIM component. That's a very impressive piece in my mind.
Oh,
That's
absolutely. I mean, the ability to do that with private data that's just a game changer for a lot of organizations. Yeah, sure, it's all fun to play on public data with things that don't really, pertain to my day-to-day responsibilities in my organization. But if I'm trying to, work on something that's internal that has not been released publicly, the ability to take advantage of all the same OpenAI beneficials that, benefactors, words are hard today, but take advantage of all the benefits of the standard APIs. That seems like really powerful.
Yeah, yeah. This is a very important component. This is going to be there as the inference engine for all of the containers that you build and the model that you use. That strange diamond-shaped atomium sort of symbol represents a large language model. It could be another type of model. It could be a VLM, a visual language model, where you're taking images and text and asking, show me all the pictures of Justin that you have in your database, or
Oh, that's a lot.
um,
I got a lot of Justin pictures.
yeah, yeah. So, this is not just about language. This is about mixing language and other media like images or videos, etc. So there are specialized NIMs for all of these. And to me, very impressive is the fact that NVIDIA has used this delivery mechanism for models to fine tune models for particular GPUs and to fine tune them for numbers of GPUs. So a Llama 2 that's been fine-tuned for 2 GPUs, 4 GPUs, 8 GPUs, for example, all of which can be assigned to a virtual machine. And using that particular name, I get the very best performance.
So you
So
can do, like you said pictures, like, pictures of Justin, sure, but like you can do PDFs, you can do photos, video, any
correct,
file essentially, and then it can learn that information in a, I don't know if the word is tag or not, but you can essentially categorize that information for future queries.
correct. Tagging is almost there. It's embeddings in some ways, but that's exactly what's going on. You hit it nail on the head. We can treat text and documents and images and drawings all as the same thing that we put into our private vector database and query them. So summarizing then, the big picture here is that we believe VMware Cloud Foundation is the fundamental basis for all of the work that I've been describing. It's got the appropriate agility and scale to be able to bring up deployments like you saw me do and tear them down a week later, bring up another one, bring up multiple deployments at one time, because you're going to have data scientists working on different operating systems, using different models, using different GPUs, and testing all that with their latest code. Virtual machines are the key way to do that. They're key to separating one experiment from another. The world of data science is full of machine learning experiments with different data sets. So you need a platform that's capable of handling that rate of change. We've got the agility to do that. You still want this to be enterprise managed in the same way that we manage hundreds of thousands of VMs
Oh
today
yeah.
inside big centers. And you want to add the privacy and security. We've got extra features inside the VMware hypervisor. Secure boot, host lockdown, VM encryption are examples of that. So VMware Cloud Foundation is the key to all of this. What I didn't mention at the beginning is, what are the key use cases that we see customers going for here? And interestingly, when somebody did code generation with a large language model inside VMware, hundreds of engineers jumped on it and said, we want to try this. And something like several hundred engineers have tried our code generation large language model now, and they actually find it a very high quality code. So this is one use case that struck me as unusual, but it's definitely a use case of large language models. You've heard me talk about customer service representatives and customer contact centers, resolving problems there, giving the customer service representative a summary of all the documents that apply to a particular case, that sort of thing. We're building LLMs into our IT operations tools, that some of which I've showed you. And anywhere that a customer has lots of documents that are private,
Mm-hmm.
investment reports in a bank, medical records that obviously can't be public, sovereign data that has to stay within the country, within my data center, all of that applies to advanced information retrieval. And that's document search, policy search, procedures for controlling access to that document. These are a few examples of the use cases that we've come across. There are hundreds of other use
Oh,
cases that will apply here. Um,
Justin, code generation is a huge one. I was just so ChatGPT was actually temporarily down yesterday. I don't know if you noticed that, but it was down like over lunch for a small period of time. And I saw some people on Twitter saying like, I had to debug my own code all day today. Like I'm gonna need a vacation. It's like people are like really taking advantage of these tools for sure. Like, but you can't do that with internal data yet. But having that, yeah. So yeah, I think code generation is a huge one. Of course, the contact resolution is a big one. Chatbots. I mean, the days of old chatbots that are not useful. I think everyone's seen those. But we start to see how things with real generative AI can really be a game changer in a lot of these areas. IT operations. I mean, Aria has all kinds of. I spoke to some folks about VMware, about Aria's suite and how they're using AI internally in their solution to just like in regular English say, hey, which servers are being used the most, or I need to do a disaster recovery plan. What would be the easiest way to do this? Just native language, and it's giving all this information and creating, and generating code for you to automate some of these operations. So yeah, these are some
we
key use cases that are going to change the way we do business.
We call it, you can now talk to your data as if it were an assistant to you. You can now, use the data in ways that you can express in English. So you're absolutely right. If code generation models have any kind of downtime at all within the company here, the complaints are allowed immediately. Get this thing back. It's become business critical to my development that we have this back online. So these are rapidly going to be production applications, and they're going to need all of the replicas and other safety measures, backup safety measures that production has been done on VMware Cloud Foundation for a long time. And there's plenty of reading you can do on this. There's a lot of news out there about retrieval augmented generation. There's a really excellent blog article that I should have put in this list by my colleague Frank Denneman, who's out of the Netherlands, describing in detail retrieval augmented generation. Go there first if you're interested in that. But if you'd like to learn more about VMware Private AI Foundation, there's a What's New blog, there's technical overview, there's performance data that show that we do equally well as bare metal on GPUs. And this is very surprising to some people, but our performance team has been measuring this for years now. And consistently they're saying to me, performance is the same as bare metal. There is no loss as a result.
Yeah. Mm-hmm.
And there's a website there at the bottom for VMware Private AI Foundation with NVIDIA. You can get a lot more material from us on this, and we're excited about this in the market.
Yeah, no, it's really exciting stuff. I love it. I know there's also there's also a landing page for view. I'll share some other links in the show notes of this if you're watching it on demand, so you'll be able to get access to more information. So a couple of things before we take off for sure. If you're watching this live and you have any questions, it's not too late to submit some questions, because we've got a good friend of mine, Ken Osborne, who's monitoring the chat. We're going to bring him on in a second. Before we do, though, a few housekeeping here. We do have a great YouTube channel that has a lot of great demos on there for various products inside of VMware Cloud Foundation. There's a deep dive hosted by Heath Johnson that goes through like all the things that you need to consider about VCF. So that's certainly one that you want to check. In terms of these VCF lives, we've got another one coming next week where we're going to be talking about workload mobility with HCX. So you can watch that on LinkedIn, YouTube, or Twitter. If you go on LinkedIn and YouTube, you can actually pre-register for those. We actually talked to Justin and some other folks on Virtually Speaking podcast, where we took a little longer conversation about some of these things. If you want to watch those, or you can catch those on our YouTube channel, but also on vspeakingpodcast.com. So those are just a couple of places where you can learn about VCF, but also Private AI Foundation. But yeah, now joining the live is a good friend of mine, Mr. Ken Osborne. Ken, welcome to the stream, my friend.
Hey guys, great to be here. Ken,
don't go too far. I'd love to see, if we could, a quick demo of VMware Private AI, because I know you work with Justin, and you guys have been talking to customers. You've been doing, matter of fact, I think you're going to be at a VMA coming up pretty soon doing a keynote, correct?
That's right. We've got a UserCon here in Minneapolis next Thursday.
Nice. Yeah, so you'll be doing that, talking about Private AI Foundation. So if you're in the area, be sure to check out that keynote. I'm sure it'll be well worth your time. So Ken, before we get into any common questions and all that, maybe you can do a quick screen share and show us a quick demo.
Absolutely. So team, first of all, thanks for being here with us today. What we're looking at here is a theoretical internal knowledge base article. And there's nothing particularly confidential about this. We're really just describing what Llama Index is. But you can certainly imagine within your own organizations having that confidential information that you may want to make accessible to a large language model. Perhaps you've got an internal service desk and you want that initial service desk team to have quick access to information to help resolve tickets. Now, what I'd like to do is just jump into something that Justin showed. And here what we're seeing are the two Private AI Foundation with NVIDIA ARIA Automation Service Broker catalog items. We can deploy an entire AI Kubernetes cluster if you want to set this up from a production perspective, or if you just want to ramp your early AI efforts and drop down as effortlessly as possible a customized deep learning VM that gives your data scientists and your developers a toolkit to quickly do their work. You can select this AI workstation. And I won't bore you with the details of deploying all of that, but what users will see after they've requested this is the screen that we're looking at now. There'll be a pointer here to go to the NVIDIA AI Enterprise documentation. We provide the IP address of the AI workstation that we just deployed. If folks want to SSH there, take a look at the microservices that are running, perhaps tune some parameters. But I'd like to drill down on to what's called the LLM playground. And this is what Justin showed earlier in his presentation as well. This is just an out-of-box, running as a microservice chatbot application. And it's provided by NVIDIA, and we think it's a great way to proof of concept your Gen AI efforts, in particular when it comes to retrieval augmented generation. Now, this is also written in a Python framework named Gradio UI, so you can easily customize this to your own environment, change logos and whatnot. But what I'm going to do here is just issue a simple query. What is Llama Index? Hit submit. And what you'll note is that this large language model, Llama 2 with 7 billion parameters, is absolutely clueless when it comes to what Llama Index is. So let's jump into our knowledge base, and we'll provide just a simple example, one way of doing retrieval augmented generation, in that I can click Add File, point it towards that internal KB article we looked at earlier, and get this uploaded into the vector database. And as Justin mentioned, converted into numerical representations or embeddings. Now, when I jump back to my prompt interface, I can effectively turn on that retrieval augmented generation capability by enabling this use knowledge base checkmark, reissue my query. And if you were following Justin earlier, when I hit submit, it doesn't go directly to the large language model at this point, but rather it dips into the private data that's been added to your vector database within the secure confines of your on-premises data center. So when I hit submit, it dips into that database, asks it whether or not it has any information relative to the Llama Index, and it passes that information into the large language model by enriching the original prompt, and we get a much more informed and reasonable response based on the data that I preloaded into that vector database. Now,
Okay.
Go ahead, Pete.
No, I was going to say, so like I'm trying to imagine this in like, so a real world scenario with that would be like if my company had a support group that had all these internal KBs, maybe talking about various hot fixes or various issues or things for debugging and troubleshooting, I could point to, but all of that information is not public, hence the private part. I can have all of those internal KBs or troubleshooting, all that information inside of that database. And then because I point to these knowledge base to this, that essentially points to that vector database that has all of this information in it, it can then scan that information, and then it can actually help my support team because it's actually leveraging these KBs that have been written or blogs, anything internal, all of that information that's internal, it's actually leveraging that as part of my support process.
That's exactly right, Pete. And the last thing we want our customers to do is expose that private internal information to the public. So you described it perfectly. And if you can imagine, that poor level 3 help desk gal or guy under the gun, measured by time to resolution in terms of closing tickets, they're frantically entering prompts here to try to deliver a more efficient and quicker level of service to get people operational again.
I like that. That's brilliant, man. That is the future. I've always been fascinated. Like heck, I was fascinated the very first time that I actually like went on my iPhone and I searched pictures for like a word, like my Blue Cross Blue Shield. If I have a picture of my insurance card, but it's an image, and you can like query it, and it'll come up with that image. I was blown away by that. But the ability to actually do a similar thing, but for internal data, and have this repository where not only can I find this information, but it can be used as part of a LLM solution that can generate real English speaking answers to me, or whatever, native language answers, for my organization. That's very powerful.
I agree. And as Justin mentioned earlier, we're not expecting our customers to train a large language model from scratch, but we absolutely want them to be able to benefit by picking the model of their choice and then bringing it securely within their data center to augment it with the information that matters to their business, right, within that secure manner. The last thing I want to show everyone, it's pretty simple and nothing earth-shattering, but when you have data scientists or AI developers within your environment quickly consuming these AI workstations, we do expose Swagger UI. So they may be using things like a Jupyter notebook to help either mine the data to check for accuracy or to write an AI application. And like any REST API, they can query the Swagger UI to understand what they have at their disposal. Here we're just issuing a very simple GET request to understand, hey, what models are available within those NVIDIA microservices that I can do RAG against or do inference against. And if I execute this, again, nothing earth-shattering here, but we get a definitive list of, in this case, a singular large language model that's accessible. So this Swagger UI is available to our customers as well.
I love it. This is beautiful stuff. Ken, thanks so much for the demo, man. I'm curious. I know you guys have been doing this a lot, and I've tried to ask a few questions that certainly had me going. But what are some of the more common questions you've been hearing from customers as you guys have been sharing the good news of Private AI Foundation with NVIDIA?
Well, I was monitoring the chat a little bit. Sorry to interrupt, Justin. There were a few things that came in, and a common question I'll ask you, Justin. If I'm a customer and I have an air gap requirement, is this solution something that I can utilize, or is external connectivity a requirement?
That's a great question. Thanks for that, Ken. Our goal is definitely to cater for air gap environments. Several of our customers have said we're air gap by definition. We can't connect to the internet. How do you serve us in that case? And when you saw the deployment of the deep learning VM, that was retrieving things from a public website, NGC or NVIDIA GPU cloud.nvidia.com. Those containers would have to be brought down in advance and stored in a private repository, like a Harbor repository that's on premise in that air-gapped environment, such that you don't go outside the enterprise walls to get that sort of thing. So we are working hard on supporting air-gapped environments. We do so today for the deep learning VM, the AI workstation. We're work in progress on that Kubernetes cluster for AI. To get that into air gap mode. Some of the operators that were mentioned at the green layer need access to the internet today, but we'll fix this and get air gap supported very, very soon.
Okay.
Yeah, great question.
Another question just came in from someone on LinkedIn. Again, questions can come in from YouTube, Twitter, or LinkedIn. So if you're out there, but feel free to ask questions. But somebody from LinkedIn is asking that this is very nice. They've been waiting a long time for this. Where can I download this and set it up in my home lab for testing and playing? Might be tricky to have a full VCF in the home lab. I know there are some solutions, but Ken or Justin, any thoughts on how people can get their hands on this?
So there are evaluation licenses of NVIDIA AI Enterprise that you can get for 60 days. And if you want to play a little bit in an unsupported fashion in your home lab, then feel free to go to NVIDIA and get hold of that. And you can get examples from VMware as well. But really, this is an enterprise solution that's based on VMware Cloud Foundation. So I'd encourage you to go for the product. if you're serious about this in use in your organization.
Fair enough. Fair enough. All right. So, Ken, you said you had a couple of other questions that have been a little bit more common that you've heard.
Yeah, just looking at this, Justin, I think a common question too is from a supported GPU perspective. Do
Yeah.
we have an opinion on which ones are currently supported today or not?
That's a great question. That was the one I was just about to ask myself there. And yes, there we do have opinions on this, and we follow NVIDIA's guidance. Of course, they make the GPUs. They know the insides of these GPUs very well. So the H100 is popular out there. Uh, that's that's kind of the flagship for this type of work now. If you can get an H100, please do. That will support large language models in the RAG style that we've been describing. A100s are also applicable. That's what I'm using inside my lab to do that. You saw the example of two A100s being applied to a 7 billion parameter model there. And finally, the L40S model, which is a hybrid GPU that can do graphics and can do compute as well. And by the way, when you go on VMware, we leave a lot of extra space for you to put more workloads than just the LLM on there. So we'll free up a lot of CPU space for you actually by segmenting that across the VMs that we're using. So there's tremendous value there in virtualizing all of this. And we virtualize the GPUs, we treat them like CPUs so that a VM that happens to have a virtual GPU assigned to it could move from one machine to another within the data center. That's very useful for maintenance purposes, for example. So
Yeah, for sure.
the H100 flagship, A100 next in line, L40S, all fully supported by this VMware Private AI solution today. Yeah.
Okay, and I know some of
And
those
more to come.
cards. I
More
know some of
GPUs.
those cards a few years ago didn't have the capacity that say some of the more recent cards have. So, what if I've got some cards that I want to team, if you will, on one virtual machine? I've got a big project, and I've got I need, let's just say I need like a really large amount of resources. Am I able to put multiple cards and assign them to one virtual machine, or am I stuck with
Yes,
one?
you are. You're not stuck with one physical GPU being allocated to one VM. We can do that as a virtual GPU setup and still vMotion the VM, even though it's got two physical GPUs assigned to it. Um, by representing the physical GPU as a virtual GPU, we're making it virtualization friendly. We're making it vMotion friendly, effectively.
Okay.
So one GPU might be too little to do a 70 billion model, for example. So two GPUs assigned to one VM is very common. Four GPUs assigned to one VM could be for very big models. And we can do 8 GPUs to one VM or higher if you've got them. You're a rich man if you've got 8 GPUs or more to add to your VM, and I'm jealous of you, but that's very doable. Those high end HGX machines or machines with 8 GPUs in them with very fast networking between them, NVLink. All of those are understood by VMware, and we tolerate adding those to a VM if needed.
Very nice.
Yeah.
Well, I'm going to leave a link on the bottom here. This is a short link, if you will, to the landing page for VMware Private AI Foundation with NVIDIA. It's a really cool solution. There's a lot of information out there. There's some great demos. There's a lot of technical information out there, all that can be found on that landing page. Other links in the show notes of this if you're watching it on demand. Justin, Ken, this has been super informative. I love it. I'm super excited. I want to thank you for joining us on the VMware Cloud Foundation Live.
Thank you, Pete. Thank you for
Thanks,
having
team.
us.
Gentlemen, take care.